Right, hello my lovers. TMUA today, paper number 1. It's the practice one, so like 2016, if it comes up like that. Let's get going. So first thing, we've got some expansion. We're given it over here. We want to find the value of p. So when we expand this sort of thing out, let's look at the first term, so the powers of x cubed. On the left, what we're going to get is a cubed, and on the right, that is 8. So we know that a should be 2. Let's do the same with the constants. On the left, we have b cubed, and on the right we have minus 3 root 3. That's the same as minus of 3 to the negative, 3 to the 3 on 2. So if we cube root both sides, what we get is that b is equal to negative 3 to the half, so i.e. negative root 3. That's good. How do we find p then? Well, p is going to be the x squared term. So where's that going to come from? We need to have a squared times b. So it's going to be a squared, which is 2. So 2 squared times by b, negative root 3. But when we do the expansion, this is going to come from Pascal's triangle as well, isn't it? When I have 1, 3, 3, 1. So we'll times that by 3 as well. So we should have, that's a 4 times a 3 is a 12. So 12 root 3, but all negative. Sorry, yeah, that's minus p. So that equals minus p. So p is therefore 12 root 3. Lovely, looks good. Let's keep, number 2 must be down here. Yep. So some other cubic thing. X plus 2 is a factor, so we know that we can put in x minus 2 is equal to 0. What's the complete factorization? Well, yeah, we've got this a here, so let's do that first. If we plug in the minus 2, minus 2 cubed is minus 8, times 3 is minus 24. 2 squared is 4, times by 13 will be 26 and 52. 2 times 8 is 16, and then plus the a, this must all equal 0. Those two give us 40. 52 take 40 is 12, so a is negative 12. So that's good. We know then with the last bits, we need to times together to be 12. So we can rub some out already if you want to. Like, it's not going to be that one. Not going to be that one. Not going to be that one. Must be one of these bottom 3. So having like 2, 3, and 2 to make a 12. That's good. Let's try and factorize this thing then. So we know it's going to be x plus 2 in one of the brackets. Let's think about the cubic term that goes with. So the quadratic term it goes with. So we've got an x. We need a 3x squared. We have a 2. We need to have a minus 12. So it must be minus 6. And then if we think about the fact that we already have 6x squared there, we need to have 13 altogether. So this bit must be 7x squared. I.e. the term in the middle of that quadratic must be 7x. That looks good. We can then go and factorize this. We can see that we must have a term of either 3 or minus 3. So if we go through and just check, is it going to be 3 or minus 3? Well, if we do normal 3, we'll get 27. That's going to add on loads in it, so that's going to be way too big. So it's going to be minus 3. So x plus 2. Minus 3 worked in there, so it's going to be x plus 3 out here. And you can see then we need to still make the big cube. So it has to be the 3x. And we've got a 2 and a 3 makes a 6. We need to have a minus 12, so it must be a minus 2 in there. That looks good. So which one is that? We don't want this one with the minus in there. We don't want that one with the positive. It should be E. 2 is E. That's correct. Lovely jubbly. Number 3 then. Line is drawn normal to this curve. So that's y equals 2x to the minus 2. If we differentiate, we're going to have minus 4, x to the minus 3. X equals 1. So that would be minus 4. But we've got the normal to that. So the gradient of the normal is 1/4. This line cuts the x-axis at P and the y-axis at Q. Find the length of PQ. Okay, so with the normal to the curve x is 1. So let's actually work out what is y of 1. That's going to be 2. So we can write down one equation then. Y minus 2 is equal to m, the 1/4, lots of x minus 1. And now we want to find out where these two values cross those axes. So if we make y 0, what we're going to get? Well, this whole thing is equal to minus 2, doesn't it? So times that across, this would be minus 8 on the left. This must be minus 8. Adding that over, x is minus 7. And if we make x 0, what do we get? Well, this whole side is going to be minus a quarter. 2 minus a quarter is 7 on 4. So we could draw this out if we like. We've got some sort of like axis like that, where we have, what we're doing, let's do a big axis. We have the minus 7 over there, and 7 on 4 there. So it's some line joining that. How do we work out the length of this line? It's going to be 7 squared plus 7 over 4, all squared, all square rooted. Take out a 7. We're going to have 1 plus a quarter squared. So it's 1 plus a 16th, that's 17 on 16, all square rooted. So take the 4 out of that, it should be 7 on 4 root 17. Is that an answer? It is. Part C. 3, the answer was C. Lovely jubbly. Looks good to me. Let's just make that 17 more 17-ish. Got some sequence now, doing some horribly ugly things, but it's less scary than it looks. So let's just work out what's actually going to go on. This power, n to the minus 1. We could rewrite that as still the negative to the minus 1 to the power of n, and then over minus 1. So that will cancel, that will cancel. Over here, this is 2 of them. So it's like we're going to rewrite this as minus 1 squared and minus 1 to the n. Well, minus 1 squared is just 1 in it, so that can go away as well. So we can rewrite this whole thing. We still got that first one. On here, the negatives cancelled out. And same thing over there. So actually, they're all the same thing. So we just have 3 dots of this thing. So let's write that sequence out. What's it going to look like? I will leave the 3 out the front. We're going to have, when n is 1 to start with, it'll be minus 1. And then when it's 2, it'll be 1. And then minus 1, and then 1, etc., etc., until we get to the 39th, which is odd. So it will be like the first one's going to be minus 1. So thinking about that then, what's going to happen? Well, these bits make 0. These bits make 0. You can see the 1 is always the second one. So that will make 0. What we're left with then is just that minus 1 on the end. So it's 3 times minus 1, minus 3. Does that look good? Number 4 was B. Lovely. Let's keep going. Total area close between the curve y equals x squared minus 1, the x-axis, and the lines x equals minus 2 and 2. Okay, what have we got then? We have some quadratic, didn't we? Doing quadratic things. We have some x-axis doing x-axis things. We need a line at 2 and also a line at minus 2. And I think that's it. So let's label these bits. We'll call that R1. This can be R3. That can be R2. What we can do to speed this up a little bit is noticing that we have an even function. So what I mean by that is if we had like y of x is exactly the same as y of minus x, because you just square it and you get rid of that negative immediately. So they are the same function. That's called even. Why that's useful here, we can draw basically a line down there where the y-axis is, and it's symmetrical. This is a line of symmetry on our graph. So we can work this out by thinking if we have like all of the area, be R1 plus R2 plus R3. Really, if we kind of think about, if I do it in green, we can have like, say, S1, and that's still R2 up there. Because R1 and R2 are the same, and then S1 is going to be exactly half of R3. So instead of thinking about all those 3 parts, we can say that it should be just S1 plus R2, but then double that because it's the same either side. That looks good. Working these out then, we need to integrate. So we do integrate y. What we get is x cubed on 3 minus an x. There is a plus c, but we're going to just plug limits into it immediately, so don't worry too much about those. What's that going to give us then? So let's call this big Y, so I can just write it a bit easier. Big Y of x. So the first one, S1, we need to take the limit from 0 to 1. So this is 2 lots of the integral, 2 lots of the big bracket of the integral from 0 to 1 of y, plus the integral from 1 to 2 of y. But you need to be a little bit careful because the S1 is negative, isn't it? So we actually want to have like the negative of that. You can think about doing modulus if you've learned about those. We want to basically just ignore any negatives that come out of this because we only want the positive value for the area. So that looks good. Let's think about what all those bits are then as we plug them in. I'll do this one first because it's got the positive bit. Yeah, so do that first, do this second. So here you'd plug in 2. And then we plug in 1 and subtract them. And this side, it's like we're going to have 0 take 1, yeah? So plus y of 0, take away a y of 1, or we got one of those in there, so we can just double that thing. That looks good. What are these things then? Let's go and work them out. Big y of 0 would be 0. Big y of 1 would be a third minus 1, so minus 2/3. And big y of 2 is going to be, that's 8 on 3 minus 2. 2 is 6 on 3, so it is positive 2/3. So let's fill the blanks in. What we've got: y2, 2/3. Y1 was 2/3, but we're doubling that, so it's 4/3. I'm making it negative. And then y0 it was 0. So in the middle, that is 6 over 3. 12 over 3 should be 4. 5 is C, is it? 5 is C. Lovely, jubbly. All looks good to me. Let's keep going. P, Q, and R are each mixtures of red and white paint. We've got 30% red in P, 20% in Q. They combine proportionally in 12, 5, and 3, respectively. If the resultant mixture contains 25% volume of red, what percentage of R is red? Okay, so we're doing a weighted average, yeah? Where these are our weights, and these are kind of also weights in a weird way. But we can think either way around, like this can be weights, this can be the values, this can be the weights, this can be the values. So let's think about having the entire container. First of all, this is 20 another month, yeah? Total there is 20. So we're going to have 12 20ths times by P, which was 30%. So times 3 on 10. Plus 5 20ths of Q, which is 20%. So 2 on 10. And then plus how much is left over, the 3 20ths, which are for R, times by whatever percentage R is red. And that needs to equal the total will be, well, we've used 20 over 20, haven't we, altogether? So just 1 times by the 25% that we should have. So it should be just 25%, 1/5, 1/4 on that side even, sorry. That looks good. Let's try and turn everything into one like common denominator. I've got 200, looks quite nice, doesn't it? So over here, that's 36 on 200, plus a 10 on a 200, plus that's 3x on 20, so it's 30x on 200, yeah? And this thing would be 50 on 200. So goodbye 200s, we don't need you anymore. And let's work some stuff out. We've got 46 there, 50 there, so that's 4, and take it away. 30x is equal to 4. X is going to be 2 on 15. So we want percent on that. That is obviously more. That's bigger than 10%, isn't it? But it is less than 20%. So get rid of you and you and you. Is it very nearly 20%? Well, that would be 3 on 15 is exactly 20%. And you think 1 on 15 would 1.5 on 15 would be 10%. We're not really closer to 20%. Like what is 20% is going to be 19.5% is going to be very, very close to 3 on 15, not close to 2 on 15. So I think it's not going to be the 19. We're much closer to the 10 than we are to the 20. You can probably work it out another way, but I think these like rule out as ones that are wrong. And it's, yeah, definitely not impossible. We got a result, didn't we? Is that correct though? Let's double check. Number 6. Yep. C, all good. What have we got now then? 60% of our sports club members are women. The remainder are men. We can play tennis or cricket. They play exactly one of them. No one plays both. 2/5 are male. 2/5 of the male members play cricket. 2/3 of the cricketing members are women. Most probably that a member of the club, choosing at random, is a woman who plays tennis. Okay, so this is like it's a very specific version of a Venn diagram where there's no, all the events are mutually exclusive. You can't be a man and a woman. You can't play tennis and play cricket at the same time. So it's like a two-way table. We can have man, woman, total. We can have cricket. We can have tennis, and we can have total. We know I'm going to do percentages. Let's actually make this into a more table, be easy to fill in. This should be 1. Everyone, like the total, there's just 1. That's the whole amount of people. So what things do we know? 60% of the sports club members are women. So in here we can get 0.6, and in here we can get 0.4. 2/5 of the males members play cricket. So let's make this not 4 but 40. I'll make that 60 as well. 40 and 60. 2/5 of 40. No, 1/5 would be 8. So 2/5 that is 16, and that's for the cricket. And therefore 3/5 must play tennis here. 0.24. 2/3 of the cricket members are women. So this must be 1/3. So doubling that for 2/3 is 0.32. Tripling it gives us 0.48 for the total. So it must be 0.52 for the tennis. So this number must be 0.28, which is 7 on 25. Pretty sure. Yeah, it's 4 times 7. Nice. So B looks good. B looks good. Let's keep going. What do we have now? Maximum angle in the range which satisfies this equation. Okay, this is just a sine quadratic in disguise, isn't it? That's cos squared, but it's also 1 minus sine squared. Just a thing on the notation, like the lower one is meaning this cos 2x or sine 2x, and the top one is meaning the power. So this is sine 2x squared. We'll add that on then to root 3 sine 2x minus 7 on 4 equal to 0. Let's take this all to the other side to make the square one be positive. So sine 2x squared, take away root 3 of sine 2x. We'd add this over to get plus 7 on 4. Take away the 1 to be plus 3 on 4. I am then also going to times it by 4. Make it a bit nicer to deal with, I think, isn't it? So 4 sine squared minus 4 root 3 sine 2 plus 3 equals 0. Find the maximum angle which satisfies this. So one thing to notice, this is sine of 2x and cos of 2x. So our 2x goes all the way to 720. Let's go and factorize this now then. Is it a nice one? Not too sure, but let's see what we have. So our discriminant will be b squared. So it's going to be 16 times 3, 48. Minus 4 times 4 times 3. So 4 times 4, 16 times 3 is 68. No, 48. Okay, so discriminant is 0. So sine 2 must be equal to minus b 4 root 3 over 4. Sorry, over 2a, over 8. So root 3 on 2. That looks good to me. What that tells us now then, 2x. I think root 3 on 2, if we did it like from degrees, it would be 60, wouldn't it? So we'd have 60. Actually, draw this out might be the easiest way. Go up, go down, go up again, up, down, up again. We want like bop, 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 and bop, don't we? So we've got a 60. So that side is also a gap of 60 from 180. So we have 120. Add 360 to both of those. 420 and 480. But we want the values for x. And we just wanted the largest one, didn't we? Maximum angle. Yeah, so that maximum one goes down to 240 degrees. And I think F for number 8. F for number 8. Lovely jubbly. Let's keep going. The line segment joining the points 3, 3 and 7, 5. Diameter of a circle. Okay, we're going to find it. Okay, so let's think what is the midpoint of this first. It's going to be 5 and 4, yeah. So that's our center. It's translated by 3 units in the negative x direction. So that's 3 to the left. So it's gone to 2 and 4. Reflecting the x-axis. So that changes the y to be negative. 2 and minus 4. And then enlarged by scale factor of 4. Okay, so that doesn't change the center. So our center's good. So we need to have something that is x minus 2 squared plus y plus 4 squared. The original, let's think about the actual vector. So this was the midpoint. The vector difference is 4, 2. So if you think about the magnitude of that, 4 squared, 16. 2 squared is 4. Add them together, I get a 20. So it's root 20 for the magnitude. So that's the radius of our circle, basically. So this should equal 20, i.e. that thing squared. But we've times by 4. So times by 4. 4 squared. So I think the radius was times by 4. So the area, this is effectively the area. It's not the area, but it's proportional to the area of the circle. And the area of the circle has been times by 4 squared. I think the radius got times by 4. So that should be on that side equal to, no, so I didn't need to square it, did I? Didn't need to square it. Just times by 80, times by 4 to give us 80. So it should be minus 2 and plus 4. They're all got minus 2. None of those ones. None of those ones. So it is D, 9. Yes, looks good to me. Just to clarify this thing, what happened then? So our radius was root 20. We times that by 4. So what is this? This is 2 root 5 times 4. So that is 8 root 5. Squaring that would be too big. What have I done wrong? What have I done wrong? Oh. No, not sure what I've done wrong. Enlarged by scale factor. I suppose that's changing it in both. Yeah, that's this way I think. That's a 2D scale factor. Then enlarged by scale factor of 4 and the center result in the circle. Yeah, so it's they've enlarged by scale factor of 4, not in just one dimension, they've done it in 2 dimensions. So we did need to times by like the radius was just times by 2. Do you mean radius times by 2, the area was times by 4. So this one was correct. This one should have been times by 2. Times that by 2, that by 2. This would become 4 root 5. So r squared would be 16 times 5 would be 80. Yeah, lovely jubbly, looks good. How many solutions does the equation x tan x equals 1 have in this interval? X tan x, no idea what that looks like, but I do know what tan x looks like. And I do know what 1 over x looks like. So I'll draw both of those, try and be as accurate as I can. I'll draw the tans first. So, what's going on? What should we have? It snaps, gone. For tan, where it comes up, does that, and does that, doesn't it? And what we have is the asymptotes. That should be at 90 degrees, which is pi on 2. And we will then get the exact same shape either side of that. I'm going to move this over a little bit. Yeah, this thing should be repeated over there. And again, over there. Where we will have more asymptotes. And these ones now are at 3 pi on 2. And then we'll get another half of the shape. So on the right hand side, we'll come from the bottom, but we won't get all the way through. And the right hand side, left hand side, sorry, we will go from the middle up to the top. So thinking about where does the line y equal x, 1 over x, sorry, go now? Well, if we draw it on there, it comes and does something like this, doesn't it? And then also from this side does something like that. Important to note that it's never going to cross that line or that line. So that this bit will not hit this bit because this one stops at that red line and this one never goes above it. Exactly the same arguments there. The blue one stops at the red line. This red line is above the dotted line. Where do we definitely have them? 1, 2, 3, 4. And I think that should be the final answer. 10. was e, which is 4. That's good. Let's keep going. The roots of this equation are p and q. P is bigger than q. Find the value of the difference. Okay, so this is just a quadratic in disguise, yeah? What do we have? Well, it's going to be 2 to the 2x all squared over there. This thing, I'll bring an 8 down the front and take it away. So minus 8 lots of 2 to the 2x plus the 12 all equals 0. So we've got x squared, or y squared minus 8y plus 12. 12 can be 2 and 6. So it should be 2x, or 2 to the 2x, minus 6 minus 2, so equals 2 or 6, yeah. Doing that then, what we have is that 2x should be the log base 2 of 2, or the log base 2 of 6. And then we can half them as well, can't we? But we want to find the difference. So the difference in x should be a half of the difference in those things, because a half from the half. You can see the difference in 2x is the difference in those, so half in that. So log of 2, or log base 2 of 6, take away log base 2 of 2. Using that in the middle, we should have log base 2 of 3 in there. So you can see we've definitely got logs going on, haven't we? It's not this, it's not going to be base 10. Where's the base 10 coming from? I say that it's going to be, there will be a base 10, wouldn't there? But it's not one of these ones, because the 2 and the 3 do not work nicely. But you can see because it's base 10, we actually need to use that kind of weird log law that you never really think about, where we can rewrite this still with the half, but then now we can write this as log of anything, like log base anything, say 10, of the 3 over log base, as long as it's the same as the one on the above, so 10, of the 2. And what we can do then, the 2 on the bottom mixes in there to make a 4. So it should be log base 10 of 3 over log base 10 of 4, which is e. Is that the right answer? 11, e. Lovely jubbly. Looks good. Let's keep going. A right circular cylinder is contained within a sphere of radius 5 centimeters. So I know that like that's 5, yeah. So that the whole circumference of both ends of the cylinder are in contact with the sphere. That just means that there's no space inside the cylinder, inside the sphere, for the cylinder to move. If you know what I mean, like these bits are pinged on the sides. It can't like, I suppose it could rotate, they could spin around maybe, but it can't like rock around in there. Do you know what I mean? It's fixed in as tight as it can be fitted. Diagram shows a planar cross section through the center of the sphere and cylinder. Okay, so they've just like chopped it in half. I don't think it matters whether the cylinder is like this end or this end. I think it is the same idea. Do you know what I mean? I think mathematically it should be the same. I'm going to draw it as if it's on the top, I think. So I'm going to say that this is R there, and this is like H over 2. So I have my circle like cylinder is that shape, yeah. So that looks good. We're going to find the maximum possible volume of the cylinder. Okay. What's going on? Well, the volume of a cylinder is pi r squared h. I'm going to make my life a little bit easier. This being h over 2 is not so nice. Let's just make it h. And therefore, like the total height of the cylinder is 2h. Yeah. So we have pi r squared 2h. And we also have the relationship from Pythagoras, where r squared plus h squared equals 25. So I can replace the r squared with 25 minus h squared. So it should be 2 pi h, 25 minus h squared. And then expand those brackets, what am I going to get? I'll have a 50. No, let's leave the 2 pi at the front. We'll leave the 2 pi. 2 pi out there. 25h minus h cubed. So now we can differentiate. dv dt will be, we'll leave the 2 pi. I have a 25 minus 3h squared. And we want that equal to 0. So h will be 25 on 3, all square rooted, or 5 root 3 on 3 for the h. We can find r with that then. What was h squared? H squared was 25 on 3, wasn't it? So we'll have r squared is 25 minus 25 on 3. So it's 2/3 of 25, yeah? So 50 on 3. That looks good. We want to find the maximum possible value of this. So can we just plug everything back in there? That's r squared, sorry, still, wasn't it? Don't see why not. So v should be pi times r squared of 50 on 3 times 2h. So times by 10 root 3 on 3. So that looks like it's going to be 500 root 3 pi on 9. E, 12? E's 12. Lovely. Looks good. Let's keep going. How many roots does this equation have? Factorizing it's not going to be so nice. It's definitely going to have 1. Like it definitely does have 1 because it's cubic. It's a quintic, is that the word? So because it's odd powered, it's the highest one. It must start bottom left, end at the bottom right. How's it get in there? By going like that. So it will cross the axis at some point. So it will have 1 at least. Easiest way here, I think, is going to be doing the turning points. So let's actually differentiate it. We'll have 15x to the 4 minus 30x squared minus 120. Let's factorize out 15. Well, we just make that equal to 0. Let's factorize out 15. Let's factorize out 15. So x to the 4 minus 2x squared minus 8. Is that the same quadratic from a second ago? I think it might be. So it should have minus 6 and 4 and 2. Yeah, 4 and 2. So x squared minus 4. X squared plus 2. So that equals 0. X is equal to plus or minus 2. So what we know then, we start in the very bottom left. We have one flat bit at minus 2, one flat bit at positive 2, and then we end over there again. So our graph is definitely going bup, bup, bup. No questions about it. It is doing that. The main question now then is our axis. Where is it? Is it down here? Is it in there? Is it up there? So either we're going to get 1 or 3. We could have exactly, like we could get repeated root as well. Do you mean could get repeated root? So we just need to answer the question then. Basically, where are these turning points? As we put the 2 back in, what does it give us? Well, let's have a look. Let's plug in positive 2 to begin. No, let's do negative 2 first on the left. So it's going to make all the things will be opposite signs. So 2 cubed is 32, times 3 is 96, but it will be negative. 8 times 10 is 80, but that will be positive. That's going to be a positive 240 and positive 30. I don't care what number it is. I just care that it is positive. Let's do the positive 2 now. I will get now just positive 96. I'll get negative 80. I'll get negative 240. No, sorry. Yeah, 240. And positive 30. That clearly is going to be negative. Like those two together are 320. They're not. So this one is negative. This one is positive. So if we bring our axis back again, we must be between the two. This one has to be below the line. This one must be above it. So how many solutions do we have? Uno, dos, tres. C. And that is the correct answer for 13. Let's keep going then. What have we got now? The terms of an infinite series S are formed by adding together the corresponding terms in two series T and U. They both start at 4, and the first terms of S are 8, 3, and 5 on 4. What's the sum to infinity of S? Okay, so we know what A is, don't we? Let's find what R is going to be. So where's this 3 coming from? Well, it's the sum of the T and the U. So the T is going to be like 4 times the common ratio of sequence T. And then for U, it's going to be the same thing. 4 times the common ratio of sequence U. And that will equal 3. Very similar thing now, but with like this, the third term in the sequence. 4 common ratio of t squared plus the version for u is going to equal 514. Divide everything by 4. Make it a bit nicer. So we know that the two sequences that we have must add up to 3/4. So the common ratios. And the squares of them, when you add those up, must equal 5/16. I can do this with an inspection, I think. So I've just like a quarter, 3/4. So can we just do a half and a quarter? Excuse me. That was my first thought. Yeah. If I have a half and a quarter, when I square those, what do I get? A quarter and a 16th. That's 4/16 plus 1 is 5/16. So yeah, it's good. The other way would be like rearrange this for one of these, sub it in, get a quadratic, solve it, figure out what they both are. But I think then that's good. I don't think it matters which is which either. No, we don't know which one's which, do we? So we know that RT, RU are equal to a half and a quarter. So the sum to infinity of S will be the sum to infinity of T plus the sum to infinity of U. Both of them had A as 4, and it's be 1 minus 1/2 plus 1 minus 1/4. So one on the left, half on the bottom. So it's going to be 8 altogether. And then over here is 3/4. So it's going to be 16 on 3 when you times by the 4. 16 on 3. 8 on 3 is 24. No, 8 is 24 on 3. So it's 40 on 3 altogether. Is that an answer? It is. What number is this? 14D. Lovely. Looks good. Let's keep going. The least possible values of the gradient of this curve at the point x equals 1 as it varies is this stuff. Okay, so we're going to differentiate. What's the easiest way to do that? Do I want to do the product rule and the chain rule, or should I just expand? I'm just going to expand everything out. This is x squared minus 4ax plus 4a squared, still with a 2x plus an a. We're going to have for x cubes, we'll have 2x cubes. For x squared, we will have minus 4a plus a. For x's, we're going to have 8a squared, and then minus 4a squared. And then for the constant, we will have simply 4a cubed. So add them all together, we'll have our 2x cubed. We've got minus 3a x squared plus 4a squared x plus 4a cubed. That looks good. We want to differentiate this. So that's y. So y dash is going to be 6x squared minus 6ax plus 4a squared. And now we want to work that out when x is 1, don't we? So it's going to be 6 minus 6a plus 4a squared. And now let's find the least possible value. So the minimum of this thing. So we want to take y dash of 1 and differentiate that with respect to a. So we're going to have minus 6 plus 8a. So equal to 0. What do we get? A is going to be 3 on 4. This will provide the gradient of this. Okay, so that's the value of this one. Let's plug that back in then to get that gradient. So y dash of 1 evaluated when a is equal to 3 over 4. Probably not the right notation, but it's, you know what I mean, don't you? Let's think what's happening. So I've got 6 minus 3/4 of 6 is going to be 4.5. And then I need to do 9/16 of 4. 9 on 16 times 4 is the same as 9 on 4, which is 2.25. So we want to add 2.25. That's 1.5 plus 2.25 is 3.75, which is 17 on No, 15 on 4. 15 on 4. Is that an answer? No. Number 15, C. It should be 25 on 4. Have I just done this last little step wrong? Let's hope I have. Because everything else looks... I think that was all okay. Let's plug this all back in. Let's see what's going on. 6 minus... I'm just going to write it down like 3/4 of 6 plus 4 times 9 on 16. So let's make everything over 4. 24 over 4 minus 18 over 4 plus 9 over 4. That's 6, that's 15 over 4. That's the same I got last time, and it is not correct. It should be minus 25 as well. That's a big thing. Why is it minus? Let me have a little double check. What time is it now? 14:06. What's gone wrong? Number 15. This isn't a 6 apparently. Did I expand it wrong? Is that what's happened? So y dash, this should be minus 14. Where did it come from? It came from this, didn't it? No, it came from here. So should this be a 7 apparently for the x squared? Let's have a look. X squared came from there, there's a 1. And from there, which is an 8. Yes. So that should have been an 8. So this became therefore a minus 7. So this therefore became minus 14. As did this one. So that's good. When we then differentiated it, this now would be a minus 14. So we have 14 over 8, which is 7 over 4 as our A. And then, okay, yeah, all this stuff changes. Okay, so not a huge mistake. 7 over 4. So plugging that back in there, what we're going to have 6 minus, we still have the 14 times the 7 over 4 plus 4 times, well, it's going to be 7 squared over 4 squared, so it's just going to be like 7 squared over 4, and then I'll get rid of that 4 there straight away. That looks good. Again, I'll make everything over 4. So I've got 24 over 4. 7 times 7 is 49. So if we had more, like 2 of those, it's going to be 98. And then this is a 49. Those two together make negative 49. 24 take 49 is minus 25. Does that look good? It does look good. Lovely, jubbly. Let me just shrink that all down ever so slightly. There we go. Number 16 then, what's going on? These log things, just get rid of the logs if we can straight away. So this top one, what's it actually saying? Well, the left-hand side, there's nothing at the front. So it's just going to be 2 lots of this. And we can bring that up the top. So 2 lots of y minus 1 is equal to x squared. And in this case, then, what we are going to know, taking everything to the power of 10, you get rid of that. 10 to the 0 is 1. So this stuff all equals 1. So y is equal to 3x. It'd be plus 1 minus 3, so minus 2. So these are the 2 bits that we have. These are the 2 equations. We just need to solve them simultaneously. Let's plug in the y values into there. What we're going to get? Well, if we take 1 away from it, we'll have 3x minus 3. Yeah. So 3x minus 3 times by 2 is x squared. So x squared minus 6x plus 6 equals 0. X minus 3 squared, just not completing the square in this thing now. So we take away 9 plus the 3 is take away a 3 equals 0. So we should have x equal to 3 plus or minus root 3. That's for x. We want to find y then. So we need to times that by 3 and take away 2. So times it by 3 would be 9 plus or minus 3 root 3. Would it take away 2? Would it? Yeah, take away 2. So y will be 7 plus or minus 3 root 3. Yep, looks good. Looks very good to me. You can rule some of these out already. Like we've got log of y minus 1. So y can never be 1. Because that makes you got log of 0, not allowed. And y has to be bigger than 1. Do you mean? Like that, it has to be bigger than 1. So this one's not allowed as well. Kind of a negative there. All the rest I think are fine from that though. So that's good. Let's keep. Oh, was it correct first? 16 was C. Yes, lovely. Number 17 then. So we've got this thing. Find the complete set of values for which it is negative. So let's set it equal to 0 and solve it. What are we going to have? Well, if cos 2x is equal to 0, we could say that this is from 0 up to 2 pi then. We don't include either of them though. So if we start at the top, we don't have either endpoints, but it doesn't matter anyway. We want both of these values. They would be 90 and 270. So that's pi on 2 and 3 pi on 2. But that was for 2x. So x itself will be half of those things. Pi on 4, 3 pi on 4. That's good. For the other one then, we're going to have that cos x is equal to negative a half. So similar sort of idea. We're going to go down. Here though, it's only 1x, isn't it? There's no 2x in there. So we only want the first bit. Like we don't have this side of the graph. When's equal minus a half? Down there somewhere. Where is that? 120 degrees. So that's pi is 2/3. Pi is 2/3. X is 2/3 of pi. This looks good. Let's see what's happening then. So we've got one gap at 0. What numbers do we have? A quarter, 3/4, and 2/3. So a quarter, 3/4, 2/3. Wrong way around for those, isn't it? 2/3 is less than 3/4. And then like there's 1 at the end as well, or pi at the end, sorry. Pi. So we need to go through, and for both of our functions, the cos 2x and the 1 plus 2 cos x, are they positive or negative? So cos 2x is nice and straightforward, isn't it? It goes through. For the first 90 degrees is positive. For the next 180 it's negative, and then next quarter it's positive again. So it's the quarters, isn't it? We're going to be positive, negative, negative, positive. Let's do some little dash lines there as well. I will maybe put the different, so you can see those bits a bit clearer. So we have positive, negative, negative, positive. Let's do a very similar thing, but thinking about like, when is this positive? So if you have that be positive, then cos x is greater than negative a half. So if I go and draw that out, it's like down there somewhere, wouldn't it? So when is it actually positive? It's like it crossed at 2/3. So it's positive before those and negative after them. So if we think about that, when are we negative together? When we multiply these, when are they both negative? Is either when one is negative and one is positive. So they need to be different signs. So there will be positive, negative, positive, negative. So our full answer should be that we need to be between pi on 4 and 2 pi on 3, or at least 3 pi on 4, but at most pi. So ones with at most pi on the end are good. We can get rid of all the other ones. It's not one of those ones. And then we need to go from pi on 4. So it must be D, 17. Yeah, lovely. Looks good. Next one then. The function is defined for all x's and zeros. When is it decreasing? Okay, so it's pretty grim looking, isn't it? Let's rewrite it a bit nicer. 1 minus x from the top. This is going to be x. It's going to be negative, it's on the bottom. We're squaring and then cube rooting. So expand that out, what do we get? X to the minus 2 on 3 minus x to the 1 on 3. So if we differentiate that, what do we get? I'm going to get negative 2/3 x to the negative 5 on 3 minus 1/3 x to the negative 2 on 3. I'm going to take out a factor of negative 1/3 x to the negative 5 on 2. So the left term, I need a 2. The right term, I need an x. When does that equal 0 then? Whenever x is minus 2. So that's our one turning point that we have. The other one is never going to equal 0. Not a possibility because it's like 1 over x, isn't it, basically? So that's good. Let's find out then whether we are increasing or decreasing. What's the easiest way to do that? I'm trying to think whether we can do some sneakiness here and be like, well, this is all negatives, but so are the powers. So if we do the second derivative, what do we get? We're going to get 10 on 9 x to the minus 5 on minus 8 on 3, sorry, and then minus positive 2 over 9 x to the minus 5 on 3. And now if we plug in minus 2, what are we going to get? I wonder if it's allowed to do it with the cube root. It should be negative, I think, isn't it? So I'm thinking that's going to be negative. Like, do our answers have just 2s? This thing, you square root. No, you don't, because it's a cube. So that retains the negativeness. Yeah, this retains the negativity of everything. This one doesn't, because it's even on the top. So yeah, that's what you think about. The odd doesn't change it, but the even does make it positive. So this would be positive, this would be negative, this would be a higher power that's positive. The whole thing is going to be positive. I think we could go through and work it out. So this is the same as 10 on 9. It's going to be 1 over x squared times x to the 2 on 3. Plus a very similar thing, but just like instead of the x squared, it's just an x. So if we plug in minus 2, what do we end up with? This is negative. Oh no, because it's going to be squared, isn't it? So no, it's all going to be positive. Everything's positive. Yeah, the whole thing is positive. So the whole thing is positive. So that tells us it is a minimum. So I think it's going to be bigger than minus 2. X is bigger than minus 2. And then there was an asymptote. Yeah, that's an okay. Okay, I think I see roughly what's going on, because we've got this sort of grimness. It's not quite the same as like just the reciprocals, but it's not too far off that way. We've got some like asymptote basically at the 0, but we're going to have like something like this. Maybe that's a bit better way to draw it. It's going to come down and do something like that and then go off, I think. Roughly, maybe not be quite right, but we have this minimum and it keeps going the other way around. Maybe from this way. Yeah, then we have that minimum, it goes up. That's a minimum. So wouldn't it be less than minus 2, would it be? Is it A then? It is A. Okay. Let's formalize how this is working. So we knew we had a minimum at minus 2. So what must happen is that we come down and we go up again. And this is the point minus 2. That was the only minimum we had. So everything to the left-hand side of that, and we only had an asymptote at 0. That's the only asymptote we had. So on the left-hand side of -2, we must be decreasing. Not equal to. So I find that a bit strange. Why can it include the -2? We'll deal with that in a second. So we have the -2 left-hand side of that. Right-hand side we shouldn't be until we get to the asymptote. After asymptote, then we need to think about what is happening. If I was to put into the first derivative up here, anything that is, because we know the powers make everything positive. They're not going to change the sign. Like, we're going to put something positive into there, it will remain positive. So when we times it by negative things, it becomes negative. So what we have is this is negative anytime x is positive. So x being positive implies that y dash is negative. So not only do we want to be either x is less than -2 or x is positive. Yes, that looks good. Why we can include the -2, I'm not sure. Function is decreasing. Dy dx was equal to 0 at that point. That's not decreasing, is it? So A is the correct answer in it. 18 is A. Yeah, it is correct. I'm not sure why they're including the -2. Because it was, the -2 is 0 in it, so it's not decreasing or increasing because it's a turning point. But either way, this is the answer they want. I think that kind of makes sense-ish. Why they're including it, I'm not entirely sure. Let's keep going. Coefficient in the expansion of this thing, of x cubed, is equal to twice the coefficient of x4 in that thing. Okay. So when you've got these like triple, you want to do binomial expansion, but it's like a trinomial, we're going to just group it differently. So it's 1 plus 2x plus 3x squared. That whole thing is grouped. So it's like that bit is the x that you'd see in the normal part of it. So if we want to find the cubic expansion of that, we have to think about like all the ones that could possibly give us a cubic. So if we have just this term by itself, it can't give us a cubic. But if we look at the x squared term from that, what will we get is going to be 6 choose 2 times by 1 to the 4, and then times by that bracket to the 2. And then we can also get that from the cube brackets as well. So having 6 choose 3. 2x plus 3x squared all to the power of 3. So these are going to give us, what should we call it? This will give us stuff that is cubic. This will give us stuff that is cubic. They'll also have, these will have squares and 4 in there. This will have right down from 3 up to 6. But if we look at the next row, the lowest thing would be a 4. The lowest thing here is a 2, then a 3. Next one will be a 4. So we don't care about that row. We just care about the cubic parts of these. So not even the entire thing, just the cubic parts. What is the 6 formula? I know it's 1, 5, 10. So it's going to be what, 1, 6, 15. Yeah, then 15, 6, and 1 in it. So 6 choose 2 and 6 choose 3 are both 15s. So what we should have is 15. And we just want to get the cube. Where the cube's going to come from there. But it's not going to be x times x. Not going to be x squared times x squared. It's going to be the bits times together. So I have 2 times 3 is 6. Times that 2 gives me 12. So 15 times 12 x cubed. That number is 180. So I don't need to write the x cubed, do I? 180, that's good. Looking at this one then, it's going to be the lower bit. So again, I will have the 15 from the choose formula. And then I'm going to have 2 cubed, which is 8. So that gives me an answer of 120. So altogether, this should be equal to 300. That's good. let's look at the power 4 in there then. Well, we're going to have 5 choose 4, which is just 5. And then this whole thing minus a to the power 4. So it's going to be just a to the power. Oh no, tell a lie. Because this is a square, isn't it? It's a square. So we want to look at the like square term. Do you mean? So it's going to be 5 choose 2. And then we're going to have minus a, what I'm doing, times by a squared. So that's 5a squared. And that should equal to the 300 we had up there. This is slightly wrong, isn't it? A squared is 60. A is root 60. Not quite right. What did I do wrong? Not 15 in that one. There's a 20 in the middle. Does that change things? Let's find out. It should be 20 then times 8. That's 160. Yeah, here we go. That's 340. So a squared is 34. So a is plus minus root 34. Is that right? 19. B? No. Oh, 2 too big. Why am I 2 too big? If I've done the same thing somewhere else. This is 340. 5 choose 2 is 10. You have to get 340 that side and 10a squared that side. It's equal to twice. Okay, so twice the coefficient of that one. So this side should be times by 2. So it should be 2 times that, 2 times that. So half this thing, 17. Okay, that looks good to me. So just to clarify then, we found the expansion of this one by firstly like splitting it up and like basically grouping these bits together. We wanted the x cubed term. So different ways that we can make that is looking at like doing the kind of third expansion term here. So you'd have this bit squared will produce some cubes, and this thing cubed will produce some cubes. If we had that without the power, we wouldn't get any cubes. If we have a higher power than that, we don't get any cubes either. Similar thing here then, we want the expansion of x to the 4. This was squared, so we looked at the second expansion. And from there then, what did we see is that we ended up with 340 of them. No. So 20a squared with 340 that side. So rearranged to plus or minus root 17 in it. Which was part B. Looks good. Last one then. Oh yeah, this thing I had a look through before, and this thing was pretty grim. So let's try and do it from scratch and see what's going on. So diagram shows a square-based pyramid with base PQRS, and this on the top. All the edges are length 20. All the edges of the pyramid are of length 20. So that include like not only these bits, but these bits as well are all length 20. So every single one of these triangles is an equilateral triangle, and then we have just a square on the bottom. Find the shortest distance along the outer surface from P to the midpoint of OR. So how many ways could we get there? We can go along the bottom like that, and then up R to O. We could go up and over. I'll do that in like a red. And then back down that side. I think that should be longer. From the shortest distance. I think, see this red bit, imagine you just like push this down. Do you think like that we could put it down that way and go that way? But that's obviously not a straight line, is it? But I think there's some other way along there, but it is a straight line. So we'll do something like that as well, where we're going like over there. And then we're coming like, we're walking around the edge, do you know what I mean? Like we're going like, oh. We're not going along the floor. Like this line isn't on the floor. This line is along the front triangle that we have. So let's try and draw draw this out. Some of them are quite easy to think about. The red one, all the edges of the pyramid are of length 20 meters. So that's 20, that's 10. So the red one is equal to 30. The purple one, we must have how long that is. So it's going to be 20 times root 2. Because we know that's 20, that's 20. So it must be root 2 along there. And then plus a 10. This one is much harder to see. So this one, what we're going to do is redraw those two triangles. So O, S, and P, and O, S, and R. I'll do it in blue so you can see which one it is. So this is going to be S and P. And then we're going to have to join like this on one side. This can be S, and this side can be O. These should all be equilateral triangles. So we're quite hard to draw them to make them be perfect, but it should be equilateral. And now we want to go from P. Sorry, what am I doing? From P. Oh, sorry, I've drawn them in the wrong. Yeah, these are in the wrong. The just labeled wrong. Do you mean? Yeah, I've done 2 S's on it. It's not good, is it? So this is this one because I want to have the triangles either side of that. Don't I? Like the blue one walks to this edge and then walks away from it. So I need to have O and S down there. One side is a P, one side is an R. And then the line that we want to draw goes from P to the midpoint of OR. So it's like that. So how do we find that then? Let's think about some distances. It's halfway. This is halfway through, isn't it? So it is halfway of just like, it's halfway of that length, and it's halfway of that length. I know how long all these lengths are because they're all, every edge here is all 20 centimeters long. So if I think about drawing like the triangle to find out the choosing Pythagoras, it's, if I split like that, this length is obviously half of this one, yeah? So this little length is 10. And I know that this point is halfway. So this little gap should be 5. Just to clarify, the entire thing was 20. So going from the middle to the top would be 10. And then this is doing half of that, so it's 5. Similar sort of way, this is going to be like, it's not, well, this is 20, this is 20. But you can think like, if this is 20, this is 10. So let's draw out another little triangle quickly, where we're going to have 20 and 10 like that. So, sorry, other way around. We'll have 20 up here and 10 down there. So what's that side? Well, 400, take 100 is 300. So it's 10 root 3. So this bit is 10 root 3. And we want another half of that. So altogether, 15 root 3 from there to there. So if we want to find the length then, we can think about doing 15 root 3 all squared is going to be 225 times 3 plus 25. This is 675 plus 25 is 700. So we want to have the square root of that. So it's 100. So 10 root 7. Is root 7 smaller than 3? It is. So that's less than 30. So that rules that out, doesn't it? And this is more than 30, isn't it? Yeah, this is more than 30 because it's at least 10. This is at least 20. So together they're more than 30. So they're more than 30. This is less than 30. So it's that one, yeah. It should be 10 root 7 for part D. 20, was it 10 root 7 number D? It was number D. Lovely. So yeah, thanks for watching. Hopefully that is quite useful. This one was not so nice at all. This was like, when I did it first time, I did it much worse. See what I had drawn down there before, it was horrendous. Not so nice to do. The rest of it wasn't the worst in the world. It's not obviously that brilliant. You just need to know how to approach these questions. The best thing to do is just to keep doing more and more of them, so you see different ways of doing things. Like in here, learning to group like that together as one object and doing it. The hardest thing I think though is like there's no calculator, so you just need to like little things like this. Like I didn't do anything wrong about that question apart from getting the wrong value there. So there's little things like that, making sure you know all of these things off your head, knowing all like the what is sine of 120 and random things like that. Do you know what I mean? Apart from that, hopefully nothing too horrendous. Hopefully it's all stuff that you can, if you see how it works, you can understand what's going on.